I will be assuming that you have read through the calculating the area of a circle walkthrough. No, that's what we're going to do. Reading assignment. So let me just go through here. I won't try to linger. I'm sure you understand the other one, but let's just make sure, go through here and see if uh, I can clear up anything. So we're talking about linear actuators primarily, uh, such as a cylinder. Cylinders receive a continuous flow of fluid until meeting resistance at the piston. And this continuous flow versus the resistance at the piston builds pressure until the pressure overcomes the resistance, moves the piston rod, and actuates the desired component. To make calculations regarding pressure, however, or force of a hydraulic cylinder, we need to know how to determine the area of the piston or bore, if you will, pretty much the same size. To make these calculations, we need to learn how to calculate the area of a circle because the area is one of the three components in Pascal's law. To get pressure, you multiply, to get force, you multiply the pressure times the area of the circle, and that gives you uh, your force in pounds per square inch. So we need to do this. So just to go over what a circle is, it's a line or a measure. What the diameter is a line or a measurement from one side of the circle going through the center of the circle to the other side. Now, I'm referencing the textbook because their illustrations and descriptions of circles are just about like mine, and they're very good, I think. And the radius is equal to half the diameter. Uh, that's a little formula just thrown in here. But when I grew up and young in grade school or junior high, whenever it was, we first started this stuff. I remember the formula radius, uh, pi times the radius squared. I remember that. And pi I remember as being 3.1416. And the radius, of course, was half the diameter. Now you can still get to where you want to be by doing that, but there are other ways to do it that take shortcuts. And we're going to cover a couple of those ways. And lastly, the circumference is the distance around the circle. Now, pi is a constant. That means it stays the same. And these little ellipses indicate that it goes from 1416, forever. There's no end to it. It's necessary in calculations involving circles. Pi is actually derived at where it comes from is the ratio of the circumference to the diameter. In other words, if any circle, if that circle and that diameter, if you divide the diameter of the circle by the circumference, you'll come up with 3.1416. So check that out in a couple of instances. But it's necessary. It's a constant, and just like there's other constants we have and will come across in hydraulics and other calculations that we do. When using the value of pi, I want you to carry the decimal 4 places as shown. In other words, not 3.14, but 3.1416. It'll be a little bit more accurate. Or you can use, if you have a T80, whatever you call it, calculator, you can use the symbol pi and instead of writing out 3.416, like if you've got to multiply pi times something, you can just hit that symbol and the multiplication sign and enter that number and hit equal. it'll generate close to the same value. For our calculations, you can assume that all cylinders are round and the bore, which is the inside diameter of the cylinder, it's the same as the diameter of the piston. We will use the following formula in our calculations for now, unless you decide you want to go different. That formula that I've used forever until very, very recently is area equals pi times the diameter squared divided by 4. You read that as area equals pi times the diameter squared divided by 4. And the area of the area is A is the area of a cylinder or piston. Moving on, D is what is the diameter of that cylinder, and pi, of course, is 3.1416. But if we look a little closer at the formula, is is there not another way? You look what we're doing. We're dividing pi first, and then we're multiplying that times 4. So if we take pi 3.4, I'm going to do it right quick. If we take pi, if I can go 3.1416 and divide that by 4, made a mistake, 3.1416 divided by 4 equals, I'm doing wrong, I got the wrong calculator. Help, help. Let's try it. That equals 78, just like this, 0.7854. Therefore, to find the area of a circle, can we just multiply 0.7854 times the diameter squared? Yes, we can. And you can too, because it's going to end up with that. That'll save you a lot of time and cut out potentials. So the area uh, now to me, and I've already changed it in my mind, is to take, if I want to know the area of a circle, I will take 0.7854 and multiply that times whatever the diameter is squared. For instance, down here, I think I got an example where it shows, and you can do this to back me up. We have a given diameter of a piston that's four cylinder that's 4 inches, and we need to know the area of it. So one way, and the way I've been doing it, is taking pi 3.1416 and multiplied times the diameter of 4 squared, which would be 16. Divide that by 4, and you'll get 12.556, or square inches. Or you can take 0.7854 and multiply that times 16 and see if you don't get 12.566 square inches. So let me do that. I just want to make sure I'm not leading you in the wrong direction. I'm going to take 0.7854 multiply times the diameter squared, which is 16, and guess what I get? I get 12.664, which is the same square inches. So feel free to calculate the area of a circle in this course. Either way, you can do the longhand way. You can even go to pi r squared if you want to. But I think that for the most part, I noticed the little cartoon character in the week 3, was it, video? he used the uh, 0.7854. So it's becoming widespread. So feel free to calculate it. Here's another one. I believe I did. Yeah, I calculated this out the old-fashioned way, or my way, old way, and all the way out. I think this squared is 6.25. Yeah, and I got 4.90. But I also did it by multiplying 0.7854 times 6.25, which is 2.5 squared, and I got a hundredths of a square inch different. So I'm hanging in there with the 7854 crowd, I think, and to do my calculations. Okay, uh, that's the circle thing, and I'm going to stop before I move into uh, some other things.